Problem on kinematical equations for rotational motion. See, the problem here is a wheel has an angular acceleration of 3 radians per second square and initial angular speed of 2 radians per second. In time 2 seconds, the angle by which the wheel will have rotated through is to be found. So, what you can do here is apply simple equations theta equal to omega naught t plus half alpha t square, where theta is the angle covered by the wheel, omega naught happens to be the initial angular velocity, alpha is the angular acceleration and t is seconds. So, if you put the values as omega naught equal to 2 and the time after which the angle is to be found is 2 plus half, alpha is 3 because it is acceleration and time is again 2 seconds. So, if you simplify this, you will get 4 plus 6, which is nothing but 10 radians. So, C option is correct. We are going to start with work, energy, power, and a few important problems in this particular session would be based on work, finding of the work. So, let us first define work. See, work is defined for a constant force as F dot S. F dot S is how you are going to define the work done by a constant force. But if the force is variable, then you will have to write a very small amount of work done, a differential amount of work done first, assuming the force to be constant, like say dW equal to F dot ds, and then integrate over the entire displacement in order to get the total work done. That would be only for a variable force, and I believe you are not required to bother much about those problems. But for a constant force, it is going to be F dot S. And then comes energy. And regarding kinetic energy, I need not have to tell you anything at all, because from high schools I think we have been always remembering the formula half mv square there for writing the kinetic energy. But regarding potential energy, I need to share a few things with you people, because potential energy is really very confusing. See, one aspect of potential energy which really has to be taken care, or the point that you are supposed to remember is, potential energy always depends upon the choice of the frame of reference. And not just that, it also depends upon what potential have you assigned to that reference. And I think it has been always our usual habit of writing the potential energy of a body as mgh. So, when you write it as mgh, please remember what reference have you chosen, from where you have measured the height of the body as h, and what is the potential you have assigned to that reference. So, under usual circumstances, when you say potential energy is mgh, you have chosen the ground as the frame of reference, from where you have measured the height h, and you have taken the potential energy of the ground to be 0. But please remember, it depends on the choice of the frame of reference and the potential you have assigned to the reference. Okay. Then comes work energy theorem. So, the statement of work energy theorem says work done by all the forces acting on a particle is equal to change in kinetic energy of the particle. What I mean by all the forces is, make a correct free body diagram, understand all the forces which are acting on the particle, write the work done due to all of them, and then add them up in order to say that it should be equal to change in kinetic energy of the particle. Fine. So, that was just a brief introduction about the session, but now what we will do is take up a few simple problems and try to understand each one of them. Here is a problem which is based on a simple graph which he has given. The graph is between force and displacement, you can clearly see there, and therefore, the area under such a graph will always give you the work done, because force multiplied by displacement should be the work done. Okay, let me read. It says the graph shows force versus displacement, find the work done, but remember, he wants the work done only from x equal to 1 to x equal to 5. So, you are supposed to note down the area only between 1 and 5. And make it a point also to understand that the area above the x-axis is to be treated as positive, because there the force acting on the particle was positive, and area below the x-axis to be taken as negative, because there the direction of the force has got reversed. Fine? Okay. So, now if you start from 1, You can see here that there is a small rectangle above the x-axis also and an equal rectangle below the x-axis also. So, this area is positive and this area is negative, that cancels, and you are left with only one rectangle here first and then one more triangle. So, the area of this rectangle will be 1 multiplied by 10 and the area of this triangle will be half multiplied by 10. So, this half multiplied by 10 will give you 5 and this 10 multiplied by 1 will give you 10, and that makes the answer 10 plus 5, which is equal to 15 joules, which is nothing but our B option. So, that is the correct answer. Here we have one problem on energy again, but the speciality of this problem is, I think I have to explain you about the conservative force which is involved here. See, what is a conservative force first? A conservative force is one due to which whenever you calculate the work done, it depends on the displacement. In the sense, if the displacement becomes 0, the work done due to such a force will also become 0. If it is a non-conservative force, the case is not so. That is, in that case, even if the displacement happens to be 0, the work done is not going to be 0, right. So, that is the difference between conservative force and non-conservative force. But why did I tell you that was, only in case of a conservative force, there is no loss of energy and we speak about potential energy involved. Fine. So, let us see, let us read this problem. A body of mass 5 kg is thrown vertically up with a kinetic energy of 490 joules. The height at which the kinetic energy becomes half is to be found. He has given the value of g. So, because the forces involved here are gravitational force, he has given the body of mass 5 kg. So, naturally it has got a gravitational force there acting on it, and gravitational force being conservative in nature, you can always conserve the energy, you can speak about the potential energy. So, half of the kinetic energy is lost and that must have got converted into potential energy, right. So, if you just write half of 490, which is 245, as the potential energy which the body has acquired, and in the way you have been always writing the potential energy as mgh, you will directly get the value of h. So, let me write it. It is half of 490, which is 245, and that should be equal to mgh, and that is nothing but 5 into 9.8 into h that you are supposed to find out. This 5 into 9.8 will be 49. So, h will be equal to 245 by 49, which makes it 5 meters. So, A option is perfectly correct. Here we have one problem on work energy theorem. Let me help you recollect that theorem once again. Work done by all the forces is equal to change in kinetic energy of the particle. Fine. So, let us read the problem and see how we can use it. A truck accelerates from V to 2V. Work done on the truck is 3 times as much work done in accelerating the truck from rest to V, same as accelerating it from rest to V, 4 times as accelerating it from rest to V, and less than as accelerating it from rest to V. So, he has simply compared the work done in various circumstances. If you look at all the options, he has accelerated the truck from rest to V and he has calculated the work done and wants you to compare that work with the work which is required to be done on the truck to accelerate it from V to 2V. He has not told you anything about what are the forces acting on the truck or what is that particular force responsible for making it to accelerate. See, there may be 100 and odd forces. Some may be resistive forces, some may be the forces which are favoring the acceleration of the truck. See, you don't have any idea about all those, but that is the beauty of work energy theorem. Irrespective of whether you know the force acting or not, you can always calculate the work done by all those forces. Remember, this is a very beautiful statement. Without knowing the force, without having any idea about the force, whether it is constant or variable, you can still calculate the work done by the force, which happens to be very strange for someone who has only by hearted the formula that F dot S gives the work done. Because when F is not given, he may straight away say that work done cannot be calculated, but that is not so. Fine. So, what I will do here is, I will write the work done in the first case, that is in the given statement of the problem, and then write the work done in all these options. But what is the statement? Work done should be equal to change in the kinetic energy. So, in the first problem statement, so the change in the kinetic energy will be half, say capital M stands for the mass of the truck, into change in kinetic energy means final minus initial. So, half m 4v square minus v square, that gives you 3mv square divided by 2. So, this is the change in the kinetic energy of the truck in the given statement. Now, if you try to find out how much is the work done in accelerating the same truck from rest to v, you have to again write the change in the kinetic energy, which happens to be half m v square minus 0, which is nothing but half m v square. And if you compare these two, this is exactly 3 times half m v square. This is 3 times this. Therefore, the answer is A option.